Let's take a look at a third example of higher order derivatives. We have y equals sine of x minus e to the 2x, so this is not implicit. We can just do normal differentiation. However, we do want to find y triple prime of 0. This notation tells us to find the third derivative, and furthermore, we'll be plugging in 0 into x for our third derivative. So before we can find the third derivative, we have to find the first derivative. We know that the derivative of sine is cosine, and the derivative of e to the 2x is e to the 2x times 2 using the chain rule. And just remember, the derivative of e to anything is itself. Okay, so that simplifies to cosine of x minus 2e to the 2x, and that is our first derivative. Now we have to find the second derivative by taking the derivative of the first derivative, this one. So the derivative of cosine is negative sine, and the derivative of negative 2e to the 2x is negative 2e to the 2x times 2, the derivative of the inside of the exponent. So we can see this will become minus 4e to the 2x, and we still have a negative sine of x out front. Let's just do the second derivative. The problem is asking us to find the third derivative, then plug in 0. Let's take the derivative of the second derivative. Well, what's the derivative of negative sine? It's going to be negative cosine, and the derivative of minus 4e to the 2x is minus 4e to the 2x times the derivative of the exponent, which is times 2. So this will become minus 8e to the 2x, and then we still have a negative cosine of x that drops down. So this is our third derivative. Now y triple prime of 0, remember, just so you know, so you remember, the question was asking for this, y triple prime of 0. So we need to plug in 0 now in for x, and that will give us the third derivative at 0. Remember what I was talking about with applications of the third derivative. That has to do with jerk, which is when two acceleration forces collide. So maybe you would have an equation, you plug in 0 for t, and that would give you the jerk at a particular point in time, given the position equation. So that is one application to higher order derivatives. I'm going to plug in 0 now. We know cosine of 0 is 1, but we have a negative here. E to the 0 is 1. So we will just have negative 1 minus 8. And I don't know why I did a second sign here, but that is equal to negative 9. So therefore, y triple prime of 0 equals negative 9. Pretty simple. That's it for this example. If you have any other questions about it or higher order derivatives, let me know.